Hi, today I'm going to show you how to use KubeTorch to do batch inference. We're going to take this simple OCR class and launch it as a horizontally scaled service on Kubernetes, and you're going to be able to run embarrassingly parallel inference over the services that you deploy. The class that we write is perfectly regular. You can see here that I'm using VLLM's async engine. The reason why I want to use async engine is because the requests will come in and VLM will automatically continuously batch them for me. That means that I can use the service for online inference as well as offline inference. You can see that I initialize with DeepSeek OCR. I can always move this out of init into a different method. I put in some pretty standard arguments, and this is all boilerplate that comes from the DeepSeek example. You can see here that I set the OS application credentials. I'll show you how to set that later, but essentially we're going to authenticate with a service account to GCS. We have some methods here, async method for download and infer, which uses then async download and then async infer, and then finally a unimplemented write back to GCS. We're going to call this 64 times per replica for all of our replicas, and that's going to do the batch inference for us. The remainder of the class is, as I said, extremely regular. This is multimodal, so it takes in a prompt as well as an image. We have some standard stuff here for using VLLM, and we have some returns. Outside of that, we have a helper here, which we don't need to get into. Once we jump down to main, I have some arguments that I have in CLI. I can call the remote service directly without CLI arguments if I prefer. But then I get down here and then I have this image. This is the first thing that is related to KubeTorch. I start with the VLLM base image, which is a nightly build that's pinned to a particular version. And then I lightly mutate that with some installations on top of that for transformers, etc., as well as installing NVIDIA utilities. The benefit of doing this is that I don't need to rebuild my Docker image for every single iteration loop. And it's very nice to be able to do these hot, dirty syncs, which take about 2 seconds to install, rather than a Docker rebuild, tear down my pods, and have to relaunch VLM from scratch. I take that image and I pass it into the KT compute, which here has 1 GPU per replica, and then I use the .autoscale APIs to create a series of replicas. Because I'm doing batch inference, I wanted just to hit args.scale for both min and max scale. If I were launching this as an online service, I would set min scale to 0 or 1. I want my concurrency to be my args.scale times args.concurrency, because I'm going to do concurrency per replica times the scale. This compute object also gets the kt.secret. That's taking my local creds path for a JSON service account that I have and syncing it as GCP data access onto the remote service. Once I have the image and compute defined, all I have to do is to take my simple OCR class, send it to compute. Once I send it to compute, I get back OCR, which is a locally callable object. But when I make calls against it, all the calls will round robin to all the replicas controlled by the concurrency and scaling of Knative in this case. I set the async execution to be true, and then all I have to do is call it a bunch of times with all my files. So I use the helper get file names. I call it with a semaphore because sometimes my local machine will blow up when I have too many calls at the same time. And then I have some standard async IO code where I just simply append each of the requests for inference, and then I wait for it to come back, and I print out some logging as the things stream back. I can briefly show you how this looks running in my terminal. So I can bring that up. I actually have it in this other tab already with the command ready to go. And I can hit run. My pods are warm and the image is cached, but I'm deploying the service now. And you can see that I found 522 files. That's the files that I have in this folder that I'm using with get file names locally. Then I'm going to go and make those calls out. While that happens, I can just show you briefly in a different terminal that if I wanted to connect to that service, I can simply SSH in. I have NVIDIA SMI. You can see that I'm occupying about 90% of memory. if I wanted to use NVI top, this will show a little bit more clearly the usage of both memory and processor. And after a second, when I come back, I can see that the results have started streaming back. The ETAs drop really quickly because of the batching, and I'm calculating these one at a time. So as the requests went in, they're all coming back at the same time, and we can see that they start streaming back to my local. And so, yeah, it's that easy to just deploy a embarrassingly parallel inference service. And you can just make calls against that service with regular Python. The last thing to call out is that you probably wouldn't want to do this from your local laptop. That's why we have the KT app APIs. Here, by adding app equals to kt.app CPUs 1, if I run this application with KT run Python instead of just Python, it will launch on a pod on the cluster and it will run there.